Welcome to the Explainer. You know, if you're a focused learner looking to build more resilient, trustworthy software, you're in exactly the right place. Today, we're going to permanently change how you build data fetching components. We're finally moving away from those naive assumptions that inevitably break our applications, and we're stepping into a rigorous, professional methodology for handling data, or, actually, more importantly, the absence of it.
Here's our roadmap for today. We'll start with Section 1, the 8:55 a.m. disaster. Then we'll hit Section 2, the 4 canonical states. Move to Section 3, the stale state, cover Section 4, the correct guard order, and wrap up with Section 5, common pitfalls.
All right, Section 1, the 8:55 a.m. disaster. Let's dive right into this, because to truly understand why this architecture matters, we really need to look at a very high-stakes, cautionary tale. So picture this exact scenario. It's Monday morning, 8:55 a.m. at a major B2B SaaS company. Let's call him Helix Revenue Cloud. Jordan Reyes, the VP of Revenue Operations, is prepping for her 9 a.m. stand-up. She opens up her team-level deal velocity dashboard, surrounded by her regional VPs on a Zoom call, and flatline. 0% velocity across the West, East, and Central regions. Now, the West VP literally just closed their largest deal of the quarter on Friday, yet the dashboard says absolutely nothing happened. You can practically hear the collective gasp over Zoom, right? Panic sets in. So what actually happened here? Well, over the weekend, the Salesforce sandbox that feeds this dashboard was emptied out. And because the dashboard had no empty state wired up, it took that empty array and just rendered it as a real, terrifying zero.
That Loom of trust took 90 days to build, and boom, it's gone in 90 seconds. But here's the absolutely crucial point. The root cause of this massive panic wasn't the empty sandbox. I mean, sandboxes get wiped all the time. It's practically a feature, not a bug. The real root cause was an engineering failure. The developer who built that component had only ever tested it with seed data that contained, say, 17 deals. They only ever built for the success path.
Which brings us to Section 2, the 4 canonical states. So how do we prevent that 8:55 a.m. disaster from ever happening again? We pivot to an industry-standard theoretical framework that acts as our ultimate antidote.
This brings us to a golden rule of front-end engineering, beautifully stated by Adam Wathan and Steve Shoger in Refactoring UI. They say, simply, design for the absence of data. A UI component that only knows how to handle the success path is basically lying to the user. It just assumes everything is perfect, always. But let's be real. The network is hostile, databases are empty, and queries fail all the time.
Now, what's really interesting about this is how we break down the 4 mutually exclusive states every single data panel absolutely must explicitly handle. First up, we have loading, which just means the request is currently in flight. Second is empty. The request resolved perfectly, but the response set is totally empty. Third is error, meaning the request failed entirely, or maybe the data is malformed. And finally, success, where the request is resolved, non-empty, and well-formed. Honestly, success should be your default final fallback, not the only thing you consider.
Let's ground this theory in our modern 2026 tech stack to see exactly how these states map to real code. For the loading and error states, React 19 gives us suspense and ErrorBoundary as our primary idioms. When it comes to UI primitives, shadcn/UI provides those awesome copy-paste standards like skeleton for loading shimmers and empty conventions. And crucially, we have to respect WCAG 2.2 accessibility standards. That means using aria-busy set to true on the fetching region and aria-live set to polite so screen readers actually announce when that loading state resolves.
Moving on to Section 3, the stale state. What if you aren't just making a simple one-off fetch? Let's transition into the nuance required for enterprise-grade applications that rely heavily on cached or pulled reads. This introduces a totally crucial 5th state, the stale state. This basically means the data shown on screen is either older than our freshness threshold or the most recent background fetch failed, so we're falling back to the cache. This exact pattern, stale while revalidate, is formalized by massive industry tools like Vercel's SWR and TanStack query. The stale state simply tells your user, hey, showing you something is better than showing you nothing, but you need to be aware this data is old.
And that brings us to a magic number, 5. 5 minutes is a highly sensible, configurable default threshold for data to be considered stale. Now, it's not a hard-coded law. You configure it per query, but 5 minutes is generally that sweet spot where a user needs to know they aren't looking at real-time metrics anymore.
Okay, Section 4, the correct guard order. We know our states. Now let's move to the highly practical application phase. How does a forward-deployed engineer actually sit down and write this code? You've got to treat this sequence like an unshakable pilot's checklist. You order your guards from the most specific interruption all the way down to the default success path. Step 1 is your error guard. Step 2 is your loading guard. Step 3 is your empty guard. And finally, Step 4, your absolute default return, is the success state with a stale badge overlaid if necessary. Let's actually test that logic. What happens if the loading guard runs before the error guard? Think about it for a second. If you check is loading before you check for an error and your panel does background polling, a previous failed fetch would trap the user in a skeleton loading state forever. The component just says, "Oh hey, I'm fetching again," and renders a skeleton, completely hiding the fact that the last attempt critically failed and the user urgently needs to see an error alert. Specificity matters here, folks. Always error before loading.
Finally, Section 5, avoiding common pitfalls. Now that we have the checklist locked in, let's warn you about the most common traps developers fall into during implementation.
Let's rapidly fire through these 3 deadly sins of data fetching. Pitfall 1. Using data or an empty array to bypass empty states. This is exactly what caused our Monday morning disaster. It renders a fake 0 instead of explicitly saying no deals moved. Pitfall 2. Failing silently by just logging console.error and returning null. Look, the console is for you, the engineer. The user cannot see your console. They need a visible UI alert with a retry button. And Pitfall 3. Lying to the user by showing a stale cache without a visual badge. If you're showing cache data older than 5 minutes, you literally owe it to the user to put a small badge saying, "Last updated 7 minutes ago."
To summarize our core takeaway, let's quickly compare our 2 realities here. The naive component, kind of like a house of cards, assumes success, hides failures, fakes zeros, and inevitably causes executive panic on Monday mornings. But the resilient component, that's built like a fortress. It explicitly handles loading, empty, error, and stale states in a precise, logical order. And that right there is the professional, forward-deployed engineer way.
I want to leave you with this final, somewhat provocative thought. Go look at the last component you built. If your dashboard's backend literally failed right now, or if the database was suddenly emptied, what exactly would your user see? Would they get a clear, helpful UI, or would they be staring at a broken, flatlined lie? Design for the absence of data, respect the canonical states, and build software your users can actually trust. Thanks for joining me on this explainer, and I'll catch you on the next one.